birds, the bees, and the grass. How many more stupid intros can I come up with?
Let's see. Well, thousands more, Alex. As we're not going anywhere.
We're not going anywhere, anybody.
You may unsubscribe, but we
are not going anywhere. We are like a pest.
We are subscribed to this.
We're subscribed to this. This is our job.
Because it is our responsibility to elevate humanity here at TARTLE.co. It is our responsibility to get you accurate news about data.
Yeah, and how it is systemically creating a positive impact for this globe and humanity's future.
Yeah, and we don't want to bullshit you.
No, why would we do that? I am not here for any political reason. This is not like a get-rich scheme. This is about I am on the side of life.
I'm on the side of helping humanity in this globe that we've got to fix. We got 50 to 70 years left.
If I know my food comes out of the ground, and when I ingest that food, it becomes a part of me, I don't want to screw that thing up.
No, I don't want my grandkids to have to face a world that is blowing up in front of them.
I literally do not make me sit here and cry on camera.
Yeah. Well, let's not cry.
Let's talk about grass, and we're not talking about Randy from South Park here.
Let's get into how big data
yeah
is used to investigate plant development.
Ooh, plant development. So there was this researcher. Can you just give me your name real quick?
Yes, Siobhan Brady.
What?
How do you say that?
Give this to me. Give this to me. Siobhan Brady.
Yes.
Yeah, okay. Siobhan Brady. Interesting.
Is that a yogurt? Doesn't it sound like a yogurt brand?
It does. So she's out in these fields next to this metal manufacturing plant, and there was toxins that are leaching into the field. And what she realized that the toxins that leached into the soil were having were being broken down through the plants themselves. So the root system of the plants are actually adapting to the environmental stressors and then almost acting as a sponge and cleaning up and breaking down these heavy metal toxins. So she's like, that's quite interesting. So she goes to school, starts to kick off her research years and starts to study this one specific plant. I'm not sure what the heck it was. They only gave us a scientific name here, but more specifically was the root sequencing.
Yeah.
So it's how do these roots actually grow, develop, and then react to these environmental stressors? So there are certain acids that sit within the plant that she was trying to sequence. So it's like hormones. A hormone creates some sort of interaction in a biological organism. So if she looked at that hormone and figured out how to map the genes that were affecting that hormone,
yes,
she could essentially see what is the thing that is actually causing the adaptation within these roots and why one species will grow and act a certain way as opposed to another. So a lot of this thing you heard, like the mRNA that we see in the new COVID vaccine, that sort of same research was happening here with the gene splicing and sequencing that was going on with her studying the root system of this specific plant itself.
Yeah, you're just tricking it. To get super basic, you're allowing it to go, especially like on the vaccine now, it's like, okay, how can we bypass these barriers, get in there, and then tell the immune system, hey, here's a threat that looks like COVID, but it's not really COVID.
Correct. And then we can analyze the effects on plants depending on how terrible we are by creating these environmental stressors on them. But the key to her was using these large sets of big data to analyze what was going on in this gene sequence. And that's so much information, even on a small little tiny plant. And so by going through that process, she was able to find out in her final thesis or whatever it might have been with her research to say, this is the hormone, this is the part of the genes, this is what's actually causing the adaptation in these root systems to change depending on where they are in the world. And that's really special because we can then measure that across many other different types of plants to see what manufacturing outfits in a certain area are actually crippling or overburdening a plant from its natural process. There's only so much a plant can do for, cycling through our carbon dioxide or dealing or breaking down these heavy metals. And when we do too much of it, then we're going to destroy it at that point. So this is a really good use of big data and analyzing flora and fauna around the globe and looking at that gene sequencing to be like, what is this maximum stressor we're actually putting on them before we break the system?
Yeah, and it was really interesting when she was doing the gene expression and looking into growth and maturity and the maturity. She was looking at it as like the genes that turned on and they would stay on during development, or they were even able to oscillate.
Yeah,
so they would turn on, turn
off.
off again, and then turn back on again. And being able to see that, say, oh, okay, protection mode, dun-dun-dun-dun.
Yep.
Okay, everything's clean, we're good. It's almost like our immune systems.
Yeah, they know when they got to put like their roots really out to pull in nutrients, or it's like, oh, this is harming us. We actually need to retreat.
Yeah, and what she said here, she went to, and this was interesting. As part of her sorghum research, Brady visited Ethiopia in 2016 with her postdoc Sharon Gray.
Yeah.
Did you hear about this?
Yep.
While they were there, anti-government protesters threw rocks at the car they were riding and killing Gray. Brady, who still had difficulty talking about Gray's death, teamed up with Gray's husband to honor Gray by collecting donations and applying for university funding to provide training opportunities for Ethiopian scientists, particularly women. Brady has hosted several Ethiopian students for short research stints, and so far, one has earned a master's degree in her lab.
Yeah.
Her colleagues, Richard Milchmore, the director of UC Davis's Genome Center, said that Brady is a first-rate scientist, but also she cares very much about the people around her.
That's what we're talking about.
That's humanity at its best.
That's humanity, especially in a
this
scientific
is the scientists
standpoint.
that we want to honor.
Yeah, these are the people we want to honor. Ones that have looked at plants, looked at the impact, and looked at its effect on society. And also, it's like, how do I align with people too? She met people where they were. Yeah, and she created opportunity to continue to push research forward about something that is extremely important, and brought the people with her that were originally, essentially attacking those anti-protesters. She's like, how do I continue to align with the people of this culture, even though they harmed me emotionally by taking the life of my friend?
And that's so beautiful. That's such a great story, because so many times we want to look at it and retaliate.
Yeah.
Instead of looking at it and how can I elevate humanity?
She took the unifying approach.
She said education.
Yeah, education.
Which is right on our...
what do we got here? Oh, yeah, number 2, educational access.
Yeah, climate stability is number 1, which she's working on. Number 2 is what she's working on.
Is educational access. I wonder what her third one is going to be. Human rights?
Yes.
She's just going to go right down the list.
We would love to have her on the podcast. That would be awesome.
I'd really love to talk to her about that. Yeah, everything. The full experience, the research, everything, and her view on its impact with the globe.
Yeah, that'd be awesome. Thank you, and appreciate all those scientists that are out there that are doing the good work.
Keep spreading your roots.